Hello everyone, let's go to the function structure. Creating a function is like making a program. First, you need to determine the inputs. So these are the parameters of your function. Then second one is to analyze the process. So it is the function statements inside your uh, function. And the third one is you print the results. So in a function, this is the return statement. Okay? So let's try to create a program that solves the interest of the money compounded annually. So the formula of this is the CI equals P times open and close parentheses 1 plus R divided by 100, and then it is raised to N, the whole parentheses, then minus the P, where the P is the principal amount, R is the annual interest rate, and N is the number of years. So to make our main program simpler, we create a function that solves the compound interest. So what should be our main program must contain? Well, it should check if the values are valid, and we should add a do-while loop just like the previous programs. Then, what are the variables we need? It's simple. Just go back and check what our program does. It solves the compound interest, so we need the P, the N, and R. It is not the Philippine National Real Race. These are variables. Let's use the amount variable for P, the year variable for N, and the rate variable to R to avoid confusion of their meaning. Is that it? Of course, we need the variable for the do-while loop, and we will use the variable quit. If we forget some variables, we can add them later. But the inputs are important for now. So we have the program that must validate the inputs inside the loop. So in line number 19 and 25, it asks and validate the amount. It must be greater than 0, otherwise what is the purpose of this program? In line number 24, since the input is invalid, the loop will restart. So we have a continue there. Then in line number 27 to 33, it asks and validate the year. Then in line number 32, the loop will restart, but the amount is also affected by this restart. We can create a loop instead of an if statement if we don't want to start from the beginning of the loop after an invalid input. Then in line number 35 to 41, it is asked and validate the rate. And line number 40, this will also affect the amount and year when they are already valid. Maybe next time we can use the while statement there. Okay? Or we can also use a function because they are doing the same thing. But for now, we will focus to the function for compound interest. After validating the inputs, we can call the function and print the result. So here in line number 43, it prints the compound interest. If you notice, it calls the function right away instead of assigning it to a variable. Well, it's better to be that way if you only need the value of the function once. But if you call the function in any part more than once, you need to store it in a variable. So the syntax, of course, is the variable name equals then the function call. Don't forget the semicolon. Then in line number 45 to 47, this is asking the user to quit or not. Then 48 to 49, this is the end part of the main function. Okay? We are now done with the main function. So let's start the compound interest function. Again, in making a function, we need to know the inputs. And those inputs should be on the parameter list. Since the function finds the compound interest, then we need the three variables. What are those? The amount, the year, and the rate. Okay? So this is the example or the code. If you notice, the formula needs a power operation, but C can't provide it. So we need another function for power. What inputs do we need to create a power function? Yes, we need the base and the exponent, like in this example or code, sorry. Now we can create the compound interest function. Okay, so we have here in line number 55 to 59, that is our compound interest function. In 56 to 58, that is the function body. We can group this only one line, but I hope that dividing them will avoid your confusion. Again, I hope. In line number 56, the user uses of the power function. The parameters are the base, which is 1 plus rate over 100, just like in the formula, if you remember. And the exponent here is the year, which is the n, which corresponds, so of course the formula 1 plus r divided by 100, open and close parentheses, raised to n. In line 57, it stores the final result to the interest variable. And in line number 58, it returns the value of the interest variable. This return statement is important because the value of the interest is also the value of this function. So this is the output part. And lastly, let's create the power function. We can't use the power function if we didn't create one. Okay? By the nature of this function, you will just multiply the base by itself, but how many times? What do you think? Yes, that's right. It depends on the exponent. So, you will multiply exponent times. Okay? Since the same multiplication process keeps repeating, then we need a looping statement. The for loop is the best loop to use in this kind of function. So we have the float power function here. So in 61 to 68, the power function, the base is b and the exponent is e. In line number 62 to 63, this is the result. It is stored in p, and the variable I will serve as the counter of loops. So it will based on how many multiplication it will perform. In line 64, the initial value of p is 1 because this is a series of multiplication. If there is a series of addition, then the initial value should be 0. Okay? Since the multiplication will be done e times, Then the loop will start to 1, which is I equals 1, and ends with E, which is I less than or equal to E. And of course, the increment is just 1. Okay? And in line 65, the new result P is multiplied by the base B in every loop. So that's from 1 times B times B times B. The multiplication is E times. So at the end of the loop, P will contain the B multiplied by itself E times. Okay? So in line 67, it returns P. The value of this function is the final value of P. So please try it and test all the possible values of the inputs. Okay? If you are still confused, then let's try another function. Let's create a function for the divisibility. If you remember, we have a program that checks whether a number is even or and divisible by 5. Let's recreate that one by using a function this time. So again, let's create a function that returns true if the number is even or divisible by 2 and the number is divisible by 5. So what could be our input? Of course, it is the number. So how about 2 and 5? How can that be an input if you already know them? You know 2 and 5. But the number you don't know yet, it can be any number. That's why the input is only the number. So our parameters should be variables. Okay, just the number. So in line number 33 to 35, that is the function that returns true if the number or num is even and false otherwise. Okay, actually it returns 1 or 0, but you can use it inside a condition. Okay, in line number 33, the data type is int because 1 means true again and 0 means false. In line number 34, that's num modulo 2 only returns the remainder, so it should be num modulo 2 equals 0, meaning num is even. In 37 to 39, it returns true if the number num is divisible by 5 and false otherwise. If you notice, the two functions have more similarities than differences, so why not mix them? Besides, what if you need a function that is divisible to any number? So because of this, we will create a more general function which tells whether a number is divisible by x, except from the number itself. Do we need another parameter? Believe it or not, you need x this time. Okay, you don't need x, but we need it. Okay, therefore we have two parameters, the number or num and the x. It is the same with the two previous functions. The difference is the second parameter, which replaces the numbers 2 or 5, and it is in the line 42. Now let's go back to our main function. If you review your past code, you can do something like that code, but with 3 changes. Okay, the changes are: first, the div by x num comma 10 in line number 16. So which checks if the number is divisible by 10. And then another changes is div by 5 open close num in line 18, which checks if the number is divisible by 5. And the third changes is even open close parenthesis num in line number 20, which checks if the number is even. You can also use the div by x function instead of using the div by 5 and the even function. What do you think is the replacement? Please try this program and answer the question in the group on how to replace the div by 5 and even function by div by x. Okay? Now, let's go to call by value and call by reference. So in the example, there are two functions that performs as calculator. All the parameters of the first function are passed by value. On the other hand, the second function has one parameter that is passed by reference. Since these functions are almost same to the previous calculator program, we will focus only on the changes. In line number 45 to 71, that is the calculator function that all parameters are passed by value. It returns 0 if there is an error and 1 if no error. In line 70, it returns 1 because reaching that part means there is no error. In line 74 to 98, it is a calculator that one of the parameter is passed by reference. This time it returns the result if there is no error and 0 if there is an error. There's no more printing of outputs unlike in the pass by value example. In line number 74, the variable asterisk op is passed by reference. So all with op will be replaced with asterisk op. Okay? So line 88 to 94, this is to notify whoever calls this function that there is an error, meaning the caller of this function knows that there's an error if op is 0. Okay? Note, the variable name of the caller of this function could be not op as long as it is the third parameter and preceded by the ampersand operator. Okay? In line number 97, it returns the result of this function instead of 1 or 0 because the op returns 1 or 0. Okay? We will now find out the mysterious caller of this function. Do you have any idea? It's no other than the main function. So in our code here, the first function gives its error status to the main function. That's why there's no need to pass by reference. While the second function gives not only the error status but also the result of the calculator. That's why there's a need of pass by reference. In a function, you can only return one value unless it is an array or a structure. But we will not discuss that array and structure yet. So it's difficult to return two values at the same time. That's why we need a pass by reference for the second value. So if you ask me why there is a need of the second calculator function, if there's already a first calculator function, that is because there are cases that the main function needs the value of the result. So let's examine the main function. But before that, just a note, these codes are inside a do while loop. That's why there's a continue statement in line number 26 and 31. Okay? In line number 24 to 27, that is called by value, and also check the error. In line number 24, since the function returns error status, the value of this function returns is assigned to the error val variable. In 25 to 27, it is a continuous statement. If there is an error, the program will go back to the start of the loop. Line 29 to 31, it is called by reference and checking the error. In line number 29, since the function returns the result of the operation, the value of this function returns is assigned to the result variable. And the third parameter is the pass by reference. And 30 to 31, it is a continuous statement. If there is an error, the program will go back to the start of the loop. In 32 to 35, the reason why the second function is needed because the first function can't provide the main function with the result of the operation. It just print, but it can't provide the main function. It is like that the first function has the evidence in a document and it reads the evidence, but it didn't give the evidence to the main function, while the second function didn't read the evidence, but it gave the evidence to the main function. In line number 32, there is no error, which means that the result is correct. In 34, it multiplies the result with the first number by calling the first function. There's no error checking because it is not division by 0 and the value of the operator is valid. You can always ask questions if you have problems. So it's now time for laboratory number 4. Thank you and good luck everyone. Okay?